Watch the sun drop towards the horizon and it reads like a perfect disk. A clean ball of fire, cut sharp against the sky. That crisp edge is the one thing about the sun your eyes get completely wrong. The sun has no surface, no crust, no shell, nothing solid you could ever land a ship on or stand against. Fly toward it and you would never hit a wall, only sink into deeper and deeper layers of glowing gas, through some of the most violent and least understood territory in the entire solar system. There is no single moment where you cross from empty space into sun. The change stays gradual the whole way down. So where does our star actually stop? And what would you run into if you tried to reach its edge? What follows is a trip outward from that fake surface to the real boundary of the sun. A boundary that sits so absurdly far away that you, sitting wherever you are right now, are technically still inside it. The edge your eyes lock onto has a name, the photosphere. It's the layer where the sun finally turns transparent and lets its light fly free, and it is shockingly thin, only about 300 miles deep, wrapped around a ball of plasma roughly 865,000 miles across. On that scale, the surface you see is thinner than the skin on an apple. Down in the core, energy is born through nuclear fusion at temperatures near 27 million degrees Fahrenheit. But a packet of that energy does not shoot straight out. It is absorbed and thrown back again and again, stumbling through plasma so dense that the trip from the core to the surface can take, by some estimates, over 100,000 years. The sunlight warming your face today set out before the last ice age ended. At the photosphere, the gas finally thins enough that light can travel in a straight line and escape. That sudden release is the glow we read as the surface of the sun. It burns at around 10,000 degrees Fahrenheit, bright enough to drown out everything near it and trick us into drawing our star as a solid circle. Look closely, and even this surface refuses to sit still. It boils. The whole photosphere is paved with granules, churning cells of rising and sinking plasma, each one about as wide as a country, turning over like a top of a pot at a rolling boil. Darker sunspots drift across it, cooler patches knotted down by tangled magnetic fields. And the photosphere is only the first skin. Keep going and you reach the chromosphere, a ragged red zone that flickers with jets of gas called spicules, thousands of them firing at once, each thousands of miles tall, shooting up and falling back within minutes. So that looks like where the sun ends. It's really where the rules start to break. Move outward from that boiling surface and something happens that took scientists decades to attempt. The temperature does not fall, it shoots up. Step back from a campfire and you cool down. Climb away from the surface of the sun and you get roasted instead. Across a thin layer above the photosphere, the temperature leaps from around 10,000 degrees Fahrenheit to more than 1.8 million degrees Fahrenheit, and in some regions several times higher still. This searing outer region is the corona, the true atmosphere of the sun. It's so faint against the blazing surface below that for most of human history, we can only catch it for a couple of minutes at a time during a solar eclipse, when the moon covers the disk and the corona blooms around the black circle as a pale feathered crown. Why a layer of gas grows hundreds of times hotter the farther it sits from the heat source is one of the greatest unsolved problems in solar physics. The leading suspect is the sun's magnetic field. Lines of magnetism push up through the surface, twist, and snap, reconnecting like overstretched rubber bands and pouring energy into the thin gas above. One favorite idea blames countless tiny flares, far too small to pick out one by one, crackling across the surface like static and dumping their heat into the gas above. The honest answer is that no one is certain yet, which is part of why we keep flying machines straight into the heat to find out. And out here, the sun stops behaving like a ball at all. The corona has no clean outline. It draws itself into long magnetic streamers that reach for millions of miles before they break and fling plasma into space. That tiny yellow circle from the sunset is, up close, a writhing electromagnetic thing with no fixed shape. This is not only a pretty crown, the corona is where the sun loses its temper. It hurls corona mass ejections. Clouds of magnetized plasma weighing billions of tons out across the solar system. When one slams into Earth, it can paint the sky with auroras and, at full force, knock satellites offline, and overload power grids on the ground. Before going any farther out, one fact reframes this whole trip. The photosphere and the corona, everything covered so far, are still only the inner edge of the sun. The real boundary is not a few hundred miles up. It sits billions of miles out, past every planet you can name, and the spot you are in right now is inside it. Keep watching, because once you see where the sun truly ends, the solar system stops looking like a string of separate worlds and starts to look like one single enormous object. So if a spacecraft flew toward the sun's edge, what would it actually hit? Not a barrier, a wind. The corona runs so hot that the sun cannot hold on to it. Its outer atmosphere is forever boiling away into space as a steady gale of charged particles called the solar wind. It pours out in every direction, and the fastest gusts top 1,000,000 miles per hour. A probe diving inward would not smash into anything. It would sail into a thickening river of plasma rushing the other way. One machine has already done exactly that. NASA's Parker Solar Probe flew straight into the corona and crossed the point where the sun loses its grip on that outflow, the closest anything built by humans has come to touching our star. It skims through the gas hot enough to vaporize most metals, shielded by a carbon heat shield doing the hardest job in spaceflight, and it pulls back out intact. And the wind it found is nothing like a smooth breeze. Parker flew into a sea of sudden magnetic kinks, places where the sun's field whips back on itself in sharp S-shaped bends. These switchbacks seem to trace to funnels rooted on the surface, and following them may finally reveal how the wind gets born and flung outward in the first place. And the solar wind does not stop at the planets. It blows outward into two main streams, a gusty, slow one and a fast one that tears out of dark gaps in the corona called coronal holes, flooding the whole solar system with thin plasma far past the outermost worlds. It's the same flow that combs every comet's tail to point away from the sun, no matter which way the comet is traveling. That leads somewhere strange. You don't orbit the sun from the outside looking in. Your path runs from deep within its atmosphere. Earth is not simply near the sun. Earth is circling around inside it. Right now, you are not watching a star from a safe distance. You're sitting inside one. To find the sun's true outer limit, you have to ride that wind all the way out, past Pluto, past the frozen rubble of the Kuiper Belt, out to somewhere around 11 billion miles from home. The wind makes that crossing too, and slowly. Even at 1,000,000 miles an hour, a gust leaving the sun today takes well over a year to reach the far edge and pile up against the dark. On the way, the wind first slams into the termination shock, roughly 9.3 billion miles out, where it suddenly slows and heats up. Farther still, it finally runs out of push and crashes into the thin gas drifting between the stars, the leftover breath of other suns. The two flows pile up and stall against each other, and that standoff forms a boundary called the Heliopause. Inside it, everything answers to our star. Cross it, and you are in open interstellar space, the territory of the galaxy itself. Scientists picture the whole structure as a vast bubble, the heliosphere blown outward by the solar wind and pushing through the galaxy like a ship through water, trailing a long wake behind it. That bubble is also a shield, holding back most of the high-energy cosmic rays that pour in from exploded stars across the galaxy. Between that first shock and the final edge lies a turbulent, frothy zone called the heliosheath, where the slowed wind bunches up and swirls. And the bubble is no tidy sphere. Dragged along by the sun's march through the galaxy, it's pulled into something closer to a teardrop, with a rounded nose and a tail that may stream out for billions of miles. Even its true shape is still argued over. This is the actual edge of the sun. Not the bright disk, not the corona, a faint invisible shell where the sun's wind finally loses. So far off that light leaving the sun needs about 17 hours to get there. Only two objects ever built by human hands have crossed it. The two Voyager probes, launched within weeks of each other and flying for a human lifetime, slipped through the Heliopause into true interstellar space. As they passed, their instruments caught the precise moment the warm, gusty solar wind gave way to the colder, denser gas of the galaxy, the count of particles from interstellar space jumping sharply the instant they crossed. They're still calling home across that gulf, their signals taking the better part of a day to crawl back to Earth and growing fainter every year. After decades in flight, they finally stepped outside our star. Everything else our species has ever made is still inside. And the boundary itself hit a shock. As the Voyager slipped through, their sensors logged a searing wall of plasma, somewhere between 54,000 and 90,000 degrees Fahrenheit, hotter than the bright surface they had left behind. It does no harm only because the gas is so thin that there is almost nothing there to burn you. The real edge of our star, it turns out, is ringed by fire. So the sun never really ends at a surface because it never had one to begin with. It ends where its reach finally loses to the rest of the galaxy, billions of miles past the last planet, which means that as long as we stay anywhere in this solar system, we have never once left our star. We were born inside the sun, and we have lived our entire history within it. That should change how the sky over your head feels. We've just followed the sun outward, all the way to its true edge. But there is one direction we have almost never gone. Straight up, out of the flat plane where all the planets sit. What is directly above and below the sun, and why is that the single hardest place in the solar system to reach? That video is on your screen right now. Go find out.